I'm blue. Thank you, lady. Okay, guys. So let me open it up. I've already been answering a few questions in office hours. Anybody who has joined us now have other questions from homework?
Yeah, I do. It was 2.3, I think. Here, sorry, let me get my notebook. Oh, here's.
All right.
Or yeah, so 2.3, the first one.
Okay.
Sorry, for page 189.
Yeah. So what about it?
It was asking what was wrong, I think. So I'm just going off of my notebook. Oh, yeah.
Yeah.
And it was the x squared for the second part, right?
Yep.
Is it supposed to be cubed?
Yep. Yep.
Okay, and then one more here. Sorry, you had corrected it on.
All right. Let's see.
Sorry,
Take a
I'm so
minute.
sorry.
That's all right. We'll see if anybody else has a question while you're looking. Is everybody else okay? Anybody else have a question from homework? I'll be a little surprised if nobody has a question.
I did need help on number 8 in section 2.4 on page 206, I believe. I had a really hard time setting that one up initially.
Oh yeah, so we're going to talk about this problem, I think, together here in a little bit.
Oh, okay, okay.
Yeah, no worries. Yeah, this is one I expected some questions on, and thankfully I'm getting it, so that makes me feel better. I don't know if you guys understand that. You are practicing things you don't use a lot. So of course I'm going to expect questions from problems that are a little bit weirder. So if I don't get them questions, I get worried that nobody's actually doing them. But we're going to look at that one together here in a little bit. Anything else, guys? So if your questions were from this glacier problem, we're going to look at that in a minute. Anything else before it? Did you find what that was, Lauren?
Yeah, it was gonna be number 4, and I think number 60. It just pretty much is the one with like finding the percentage, like
Yeah, so here, right, this one, number 4. Let's see.
yeah.
So whenever they say what percentage of the volume of the can, that's going to be on the bottom. So out of the volume of the whole can, how much does the volume of the 3 balls take up? So it's going to be out of the volume of the can total. How much space does the volume of the 3 balls take up? Percentage is always a ratio. It's a part out of a whole. So the part is the part of the can taken up by the tennis balls, and the whole is the whole can. So part divided by whole. So you figured these two things out up number 2 and 3, I think. I can't remember. No, number 3, volume of the can, volume of all 3 balls. So you just take your answers from the 3 and put them in here. Is that all right? No? Hello? Are you still here? This,
I'm so sorry, I was muted and I was talking. But I was saying how, yeah, that's exactly what I did, but maybe just my numbers are wrong, because even the percentages that came out were kind of like wonky. Is there any way that you could set up, I guess it'd be 6C.
Whoa, what, wait, let's stick with number 4. Why are we going to 6?
Oh, I'm sorry. Yeah, that's what I meant. I'm so sorry. I was looking down at the other one that was a percentage as well.
Oh, yeah. So the way that you do this one was the same way you're going to do that one. What'd you get for this on number 3?
Oh, number 3, I got horribly, horribly wrong. So.
Oh, well, that's going to suck, because if you get 3 wrong, there's no chance in hell for 4, because 4 uses the answers to part 3. So let's see. The answers to part 3 are each piece of this, right? Number 3 wants the volume of the can. Well, that's right there. And the volume of all 3 balls, which is almost right here, you just got to change that to a 3 there, right? That exponent.
Yeah.
Is that all right? So if you just throw each of those pieces by themselves into the calculator, you should get your volumes that you need for number 3. So it could be a mistaken way to put it in your calculator possibly. So yeah, so it might be just how you put it in the calculator. I don't know. So let me show you an example I'm going to put this first one in the calculator. Or was it, maybe it's the second one that really gives people trouble. Let me see, let me share this. All right, so let me do the second piece. Oh shit, that's not the right thing. Where are you? There you are, okay. So the second piece is
Jeff,
3, yeah.
I'm sorry to stop you. And what do you call this calculator again? The calculator
This
that
is
we
the TI calculator. It's not the one you necessarily need, especially if you're not going to go into statistics after this. But if you're going to go into statistics, you might as well get this bad boy and get used to it, right?
Yeah, so it's TI, and what's the other calculator that?
No, so it's a TI 83 or a TI. This one happens to be a TI 84. It's one of those two that you're going to need in statistics.
All right.
If you're just going into 120, you could probably do with just a scientific calculator, right? And those cost about 15 bucks. So let me see, this will be the second piece, 3 times 4/3, right? So that's good so far, 3 times 4/3 times pi. And again, if you don't have a pi button, you can just put 3.14 up there. Times 3.3 to the 3rd power. So that's, and to be honest, so this is what it looks like for some people. And that's what you're supposed to get. And if I go back to my new mode, don't worry about all that shit I just did. It looks like that with a true exponent like that, right? Not just with a little caret. But it depends on if you have a newer or an older calculator, what it's going to look like. So that's what it's supposed to look like in the calculator to do that second piece, to find the volume of the 3 tennis balls. Do you see what I'm saying? So I don't know if that helps you. You can find where it went wrong, but this is what you're supposed to get right here.
Yes, thank you so much.
Okay. Because that really sucks. Like when you have the formula set up correctly and then it just comes out to the wrong answer, I'm like, oh, damn. You know, but anyway, so that's, calculator gets in the way sometimes. All right. How's everybody else? Any other questions besides the glacier one? We're about to do that.
For the percentage, you move it twice to the left, twice to the, yes.
Yeah, so when you get a decimal, you got to, no. To go from a decimal to a percent, you got to move it twice to the right.
Oh,
Yeah, got to make it bigger. The percent number is always bigger than the decimal number.
okay.
Yeah. Okay. All right, guys. So I don't hear anything else or see any other questions, which makes me a little worried, but I'm going to keep going. So let's look at this
And,
glacier.
hey, Jeff,
Sure. Yeah,
do you
go ahead.
mind? I'm sorry. Do you mind if we go over the? Would you mind if we do at question number 1 on lesson 2-4, page 199?
Oh, wait a minute. No, so wait a minute. All right.
No.
So just to make really sure with you, this is fine. You can ask me anything out of the book, but just to be sure you understand, this is not the homework, right?
I mean, I think the homework was the application. Unless this was the homework, then I could.
No. Like I just said, this is not the homework, but we can look at it for sure because it's extra practice. Why not?
I guess. And
Yeah.
even if it was a homework, we can change the numbers. Like we can use all the figures just the same, something that relates to that question.
Yeah, that's the idea, practice. So a problem like the ones you're going to see, and that's why they put this here. So instead of doing these problems, I made up a bunch of problems myself that we did together. But we can look at these two. This first one's a little bit nifty. What is meant when we say a car is traveling 75 miles per hour? So what did you think? What does that mean?
Well, I'm still, explain. All right, give me a second. I'm a slow reader, so.
Oh, all right. I just thought you had already done something with this. Is that
No,
what
I'm
you're
just
asking?
looking at it right now. I mean, I'm asking questions. Unless you want to move on, this is still due till tomorrow, right?
I think I can't remember what the due date is, but so all right. You can always ask to do a problem like something in the homework, and I could do that. You can always ask, what is this idea? Can you go over a problem about this idea? And I can do that. If you've already tried something out and you say, I got a problem with this, I can't make it work, I can look at that, right? But we're not going to sit here and
Okay.
does that make sense? So if you
Yeah,
have a
that makes sense.
specific question about something here, I can help you with that. If you want to, if you're interested in the answer to this, we can talk about that, right? But we're not going to kind of blindly pick problems and
Okay.
do them without even knowing. Does that make? I really want that to
That
make
makes
sense.
sense. Yes.
Okay.
Yes.
Um,
Kind of shooting myself in the foot, but I mean, ideally, I was trying to see if you're gonna do like a practice question, something related to this. That's ideal. I wasn't requesting to get the answer for number one, since it's the
no,
homework.
no, no. This isn't even the
But
homework. I don't care. I could tell you the
okay.
answer, and I won't care anything because this isn't the homework, right?
Well, I'm not asking for the answer. I'm asking on how to
I-
do the problem.
all right.
Like,
But all right. All right, Sal, you gotta stay with me. You didn't
okay.
try this problem out. You didn't know what it was about. So I don't know. You're not asking because you needed help, right? But if
Right.
you're
You're
curious
right.
about
Yes.
this,
You're right, sir.
all right, yeah. So the best way to get help with something we've talked about is to either have a specific problem with something you've tried, or be interested in an idea we discussed, not really understanding it. So I could do a few examples of an idea. Does that
Okay.
right? So I can do all that. That's beautiful. I can do all that shit. I can come up with problems like crazy. But we're not going to sit here and do something we haven't looked at all yet together, not knowing if it's going to help. Right? Yeah. All right. But if you have a specific question from a homework problem, feel free.
No, we can move on. I mean, I guess.
Okay.
Yeah, we can move on. Don't mind what I ask.
No, of course I do. Just
No, you're
try some
right though.
stuff out.
I have to review it myself so I know what questions I'm asking.
Yes. Okay.
All
So
right.
let's look at this one real quick. I want to help you guys with this one. A few of you guys have tried this problem out. Several of you have not gotten here yet. So I don't want to do the problem for you, but I want to give you an idea of how to do this. So let me let you read through this. And if you've never seen a glacier, you probably want to try to do that before, we destroy them all. All right, Greta Thunberg. Sorry. Thankfully, nobody shouts fake news when I say that. That's always encouraging. All right, so this is kind of funkadelic. You got this big old glacier, and it's moving 203 millimeters per day. And they want me to change that to inches per hour. Right? Okay. So can you go from, so what length is it currently in? So if I write 203 millimeters per day, what do I have to go from for length? I got to go from millimeters to inches. And do they give me a way to do that?
So they gave us the inches, the 1 inch. How much is it?
There you go. They give it to me right there,
Yeah.
right? 1 inch is 25.4 millimeters. That was very nice of them. Okay. Because if I look back at the table, I know 1 inch is 2.54 centimeters, but then they moved that decimal over and made it millimeters. That was very nice. So for example, to get rid of millimeters, where would I put millimeters?
Bottom right,
So that they cancel.
cancel it out.
And what would I put up here? Because I want to go to what?
You want to go to 1 inch there, and then the 25.4 bottom.
I like it. And so what unit is still alive that I don't want in my
Day.
original?
Day.
Days. And I want to kill days and make it into
Hours.
hours. So now where would you put days?
Days at the top.
Yeah, so let me stop for a minute. We did a problem like this where we had multiple in a row. And I want you to get more comfortable with this. Some of you guys, I think that some of you guys don't really trust me when I say, do you see how this is not that crazy? If I want to go from something to something else, I just put the unit I want to go from, so that kills where I currently, these canceled. I'm no longer millimeters. I'm now an inch if I do 203 divided by 25.4. So I don't want to be days anymore. So I have to put, I don't just put day down here. I don't just always put it, I put it up here. Why?
Because you want to cancel it.
Because now it'll cancel. And down here I can go from days
24
to,
hours.
yeah. And now I just did the whole damn problem. I didn't really mean to, but damn it. But I mean, once you see this one, I really want you guys to be more comfortable with this, because this method makes it less purely mathematical. It's just put the unit in the place where it'll die, and then put the unit in the other place that you want to go to. So I want to kill millimeters, and I want to go to inches. And then you fill that in with what's true. And then I can keep going. So now I want to kill days, and now they're dead because I put day up there, and I could put hours down there. So what are the units going to be now? What unit's left alive on the top? What
The
unit
inch.
is still the inches?
Inches. Inches and hours.
And hours. Inches per hour, which is exactly what they want. So what am I going to do? What am I going to put in the calculator? 203. What do I do with this?
You divide that.
Good. And what do I do with this? It's on the bottom, so
You divide that.
there you go. That's what I put in the calculator. If it's on the bottom, you divide by it. If it's on the top, you multiply by it. And we know that. We know that's true about fractions, right?
Hey, Jeff. And
Yes.
back to this question. So I guess the top always means part and the bottom means whole in a fraction. That's always the rule of thumb, or no?
A percentage means part divided by whole. And so a percentage, a fraction that comes from creating a percentage, specifically means part out of whole. These fractions here don't mean that. This means a day and 24 hours are the same thing. So this fraction is actually 1. Remember we talked about that?
No,
So
I don't
it is
remember.
legal.
I'm not going to agree. But
Okay. What's a day? If you divide a day by a day, what should you get? If you divide 1 day by 1 day, what's that?
you're going to get 1 day. I mean,
No.
0.
If you divide, what's 2 divided by 2?
2 divided by 2. So I mean,
What's 2 divided by 2?
it's going to be, isn't it going to be 2 still? God damn, Jeff, I'm killing you. It's going to be 1. It's going to be 1.
Yeah.
So if you divide 2, it's going to be 1, I guess.
So if you divide something by itself, you're always going to get what?
You're going to get 1.
1. So what's a day divided by a day?
A day divided by a day. So how would that even equal 1?
Listen, Sal, what did we just figure out? If you divide something by itself, you always get what? What did we just figure out? If we divide something by itself, you always get
1.
1.
1.
Because they cancel each other out, right?
Yes.
Okay, and also because 8 divided by 2, for example, is 4. Why? Because 2 times 4 is 8. So the answer to a division problem is what the bottom needs to multiply by to make the top. So what do you multiply 8 by to make 8? 1. What do you multiply 7 by to make 7? 1. Right? Yes, yes. So anything divided by itself is 1. Yes?
I like it.
Yes? No?
I
What's
said
1
yes.
inch
I said
divided
yes.
by 1? And you said, okay. So 1 day divided by 1, but isn't 24 hours, is that a day? Is 24 hours the same as a day?
I mean, yes, because there's
Yes.
24 hours in a day.
Good. So what's 1 day divided by 24 hours? Well, it's 1 because 24 hours is a day. Something divided by itself is 1. A day and 24 hours are the same thing, aren't they?
I guess, yeah.
No, no guessing. You know a day is
I
24
mean, I
hours.
assume yes, yes.
No,
yes.
no assuming. Stop saying
No, I
guess
mean,
and assume.
it's
You
it's
know
obvious
a
that it's
day.
gonna. It's obvious that there's 24 hours in a day, so we're gonna use.
So
one
see how
in that.
we combine two things. Something divided by itself is 1, and a day is the same thing as 24 hours. So if I have 1 day over 24 hours, that is 1. And I really want you guys to get this. So when we do this number stuff, we are changing the units we're using to measure something. We are not changing the thing I'm measuring, right? So if somebody says, I'm 4 foot tall, and we say, oh, you're 48 inches tall, huh? They're not gonna go, don't change my height. Did we change their height? Did we change their height? Did we change it? If they say they're 4 feet and we say, oh, you're 48 inches, this little kid, did we change their height?
I don't think
Somebody
so.
help me.
You just change the unit.
I
Yeah.
changed the units. Aren't these the same thing?
Actually, they're the same thing.
Are the numbers the same? No. But doesn't 4 feet and 48 inches measure the same distance, measure the same height in this case, right? Yes?
Yes. 12 times 4.
I like it. So when we do this process, we are changing the number we have because we're changing the units we use, which is exactly what happens in this kind of situation. So what I'm doing is I'm not actually changing the amount, the distance or the time because I keep multiplying by 1. This is multiplying by 1. I'm just changing the number in the units to stay together. Right? So if I make 4 feet, if I said that was the same thing as 4 inches, that's insane. The 4's got to change because the units changed. All right, so I might be going a little too far with this, but I really want you guys to see those two things in action. I am not changing its speed at all. It's still the same speed. I'm just using different units, which means the number's going to change with those units. Okay. I like it. I like it.
All right.
Nothing major.
Thanks, Jeff.
Okay.
Thanks for explaining.
Sure. It's with this kind of example, it's kind of silly. You're like, well, of course those are the same thing. And then I get to this example and you get a little lost, but we're doing the exact same thing. It's just weirder units, more steps, weirder numbers, same idea.
I get.
So just out of curiosity, oh, go ahead. Sorry.
Go ahead. Go ahead.
Anybody do this yet? Did anybody calculate this yet?
It's 333.333.
Yeah, sounds about right. Because 203 divided by this is about 8. Divided by 24 is about a third, and that would be about a third. Yeah. So 0.33, whatever the hell. What would the units be? You already told me. Inches
per hour.
So is it still going the same speed? Of course it is. This is the same as this. They measure the same amount of distance in the same amount of time. Just because I change the units, the number's going to change. Okay. Okay.
You know what I'm confused about, Jeff? Like I'm right now I'm all over the place, but I'm literally trying to understand. I'm trying to understand
Sure, sure.
how you get your answer. That's my question. So when I see you get a response, I'm like, shit, like I lost myself here.
All right.
I was
What do
paying
you mean by
attention there.
how I get my
Well,
answer?
I
What
mean,
do
I
you
see
mean?
the answer for this problem,
Sure.
but in most cases for other problems, like when I go back to the pie, like sometimes if I can't see how you got the answer, how to understand your form, how you get to the answer, what throws me off, like I'll stay stuck on it till I get it. And then,
Well, you have
but
to. So when you
here
have
I
a
see,
problem,
I see what you're doing.
Sal, when you have a problem like this, you have to try to see where is it that I understand and where's the first place I don't. And then you ask a question about that place, right? So let's
But hey, Jeff, I'll make sure to ask the questions after class or before class so we can continue with the lecture. And I'll make sure to write down what I'm confused about. Like that, I don't stop you too many times during class and you know um, interfere with everybody else
no,
learning.
you're fine, dude. It's up to me to say it's enough or not. But
Okay.
I mean, I think everybody's having some trouble with this. So it's fine to ask questions. Everybody's gonna get some help from this. So maybe it's better if we do a different problem. Let me see. Let's do a problem up on the board. I'm gonna get rid of all this stuff here.
All right. Thank you.
Okay. All right. So, give me a minute. I know I probably got to adjust things. Yep. So, all right. Let me see. What can I say here? All right. Well, let's use something else here. Let's do. Well, let's see. We got 1 inch is 2.54 centimeters. That we know. Let's see. We got 1 foot is 12 inches, right? We got 3 feet makes a yard. So these are all things we should probably know. Maybe not the first one, but these two you know for sure. And then, so what if I had something that was moving 7 yards per second? And I want to know, well, how many inches, let's say how many centimeters per hour is that? All right. So let me stop for a minute. You guys with me on the question?
Yes.
Let me put you guys back over here. There you go. Hey. All right. So one level of this is to trust in the process, but that doesn't mean you don't try to understand the process. So I try to get you guys to understand that it's all about either dividing or multiplying. That's what conversions are, right? Sort of like if I have 48 inches, you can kind of see that you divide by 12 to make that feet. Are you guys with me? So if I had 48 inches, how many feet would that be? You divide by 12 and you get 4. Your brain kind of latches onto that very quickly. And your brain also knows how to divide simple situations. All the grid does is it helps us determine when I'm supposed to divide and when I'm supposed to multiply. And it does that by focusing us first on the units themselves. So it kind of tries to break it down for us. So how can it go from yards to centimeters? What path do I have to use to get that? Let me put the question up here. I'm going to need some more room. How can I go from yards to centimeters? What path do I take? I can go from yards to
inches.
We go to yards.
yeah. Because remember what we do the other day? Didn't we make a yards to inches? What was the yards to inches?
But
36 inches per
36?
yard.
So we can combine these two steps into one step. We did that. I think we did that yesterday. Look how excited I am about that. So we can make our own better conversions. I like it. So now I'm going to have one less step. So I can go from yards, not to feet. I can go straight to inches. Shoo, with this. From yards to inches to, where do I want to end up?
Where you at? Centimeter.
Yeah, so I can go
Centimeters?
from inches to centimeters, which is where I want to be. So that's the complete path for changing yards to centimeters. I like it. So let's do that. Where would I put yards?
Yards on the bottom right. Am I still okay? Yeah. So you put your feet there.
So that would be 1 yard.
And that'll be
All right, now let me stop right now. If anybody is not with me, let me know.
yeah.
Yes.
But why, when you're going back to centimeters from yard inches into centimeters, why are you skipping? Oh, you're not skipping feet.
Yeah, I'm not skipping feet because what we did yesterday was, so I could go from yards to feet to inches, but what we did is we realized if 1 yard is 3 feet and 1 foot is 12 inches, then 1 yard must be 36 inches. How many inches is 3 feet? If 1 foot is 12 inches, 3 feet is how many inches?
So your timings,
Why does it make sense? Why does it make sense? If 1 foot is 12 inches, 2 feet would be
24 inches,
24, so 3 feet would be 36. I like it.
36.
So 1 yard is 3 feet, which is 36 inches. So I can make that into a 1-step conversion instead of a 2-step conversion.
So you're gonna multiply 7 yards.
Why did I go feet here? Why are you guys telling me feet? I love you guys. Yards to inches. So 1 yard, what would I put up here? Not feet.
36 inches.
Yeah, there we go. Okay.
But you put feet for what reason? Was that a mistake?
A mistake.
Yeah, I can't remember if it was me or somebody that told me to put feet up there. I wasn't thinking, but we have this more direct route. Yes. All right, I like it. And then I can
We're going
go
to cancel out the yards.
Yeah, so now I've gotten rid of yards. Now I'm in inches, and so but I still want to go to centimeters. Right? So I don't worry about this shit. For one thing, now I'm just thinking about how do I kill inches? How do I kill inches? Where would I put it?
To the bottom right. Bottom.
And inches to centimeters. That's where I want to go. So then I would put
1. 2.54.
I like it. So I really,
Kill off your
really,
inches.
really want you guys. Yeah, you kill the inches, and now you've made centimeters. And now let's see if we can do another one. Because what do I still have that I don't want? I don't want seconds anymore, do I? Yeah. Let's see if we can make a 1-step. Now listen. 1 hour is how many minutes?
60.
60 minutes. 1 minute is how many seconds?
60.
60 seconds. So 1 hour is how many seconds? It's the same thing we did here.
60.
Yeah, 60 times
360.
No. 2 zeros.
Oh, 3,600. Yeah.
Yeah, so 1 hour is 3,600 seconds.
Seconds,
Now
yeah.
you could use that if you want to, right? So now I can go straight from seconds to hours. Where would I put seconds?
Top.
Top. And hours, so this will be 3,600. I'm gonna get something huge. So look what's left over. Seconds die, seconds die. Look what's left on the top. Centimeters, right? Is left alive. On the bottom, hour, centimeter per hour. I can see that I'm gonna end up in the right units. And now I just got it. Now comes the real math.
Right.
And it looks like I'm just gonna multiply everything straight across, right? Yeah. So it's gonna be kind of huge.
Are you looking for that?
Yeah.
2304288.
Yeah, sounds about right.
I like it.
2 million centimeters. I like it. The number doesn't matter to me as much as understanding how to set this guy up. And what helped is we figured out the path that we're going to take. And it really, really is just put the unit where it's going to cancel and then put the other unit you want to go to, the one that you have a conversion between.
You know what I like about this, Jeff, real quickly? Is that she could chunk some of that stuff together and like you did the 3600 seconds and made it into 1 hour. So
And that's
some of the
this is
more
where-
obvious stuff you could chunk together and then to cut down a bunch of.
Yeah, and
Right.
this is an example of how you make math your own thing. You can make your
Yeah,
own
that's-
conversions that
that's
out of
awesome.
7.
I
Yeah,
like it. Yeah, I like it.
cool. I like it. All right.
I have a question.
Yes.
So the answer, I'm just confused how it's being read. So is that the answer for centimeters? And then what's the answer for hours? That's what I'm
No,
like.
no. So if
Okay.
I ask you how fast was that guy going and somebody says he was going 80 miles per hour, you wouldn't go, wait a minute, what's the answer for hours? Because,
Okay.
right, doesn't make any sense. It's a rate. So this is a single answer. It's this
Got it.
many centimeters per hour, which is kind of related to the question Sal was asking earlier. That means every hour it's going to move this many centimeters.
Makes sense.
I like it. I like it. I like it. Okay. And kind of another way to answer your question is it's 1 hour, isn't it? It's this many centimeters per 1 hour because all that's left on the bottom is 1, right? Right. All right. That's the basic idea behind converting. So if I know conversions, I can set up a path. And the more conversions I know, the shorter that might be. So if I didn't use this and use these, there would have been a whole other thing in here, right? To go from yards to feet to inches. All right, let me clear this. Let's do one more. I'm going to clear all this. So everybody got what they want from this? Probably more than you wanted. I'm going to get the top of that in there. Yeah, I don't know why I need to. Just do. All right. All right, this is all going away. Bye. All right, so let's say I'm working a job and I make in another country and I make, not dollars. Let's say I make 4.80. What do you got, Jeff? I can't use a real currency because I don't want to look up the currency conversion. So I'm going to say 4.80 clams.
Gold pieces.
Gold pieces, I love it. I have to look at the conversion for that too. So I'm just going to make something up. 4.80 clams. I make 4.80 clams per, you can do it, Jeff, per minute. I love it. All right. And I know that, let's say that, I know that you can do it, Jeff. Can you do it? I don't know. It doesn't seem like you can. I know that 1 clam is $4. All right. So how would I change this into dollars per hour? So we put 4.80 clams per 1 minute. So which one of these do you want to kill first? I don't want either one of these units left alive. I want to make it dollars per hour. Did I do the same thing? I did. That's good, Jeff.
Do you do how many minutes in an hour?
Yeah, okay. Sure. So let's kill minutes first. So I can go from minutes to hours. So where would I put minutes?
At the top.
All right, so 1 hour is 60 minutes. So now I've killed minutes, and now I got clams per hour, but I don't want clams, especially because I don't like clams. But so what would I put?
Clams on your bottom.
Clams on the bottom because I want them to die, and I can go straight to dollars, right?
Right.
And that would be
$4 for clam.
yeah.
Here you
Now,
clam.
first I was trying to make one that had division, and I thought backwards, but oh, too bad. But here, if I did have something down here, I would just divide. But the important thing here is the
Fill the
units
clam.
I don't want do cancel, and I do end up with dollars per hour. I can always make sure that I end up where I want to be. So now I just multiply all this stuff to see how many dollars per hour, and it's a lot of money, so I'm not sure what I'm doing.
11.52.
Is it $11.52 per hour? Oh yeah, dude. All right. Making more money per hour than Donald Trump paid in taxes for like several years. That's crazy. Yeah, what a great joke on all the American people. But oh well.
Need to sell clams.
All right. So wherever this fictional place is, if you find it, let me know. Let me see. I don't know. Does that help out at all? I think people, there's a level of this where people don't quite trust it's as easy. And some of you guys are like, what are you talking about easy? But I think that's part of it, is you don't accept that it is just as simple as putting the unit you want to kill across from it, and then the unit you want to go to there. And why is this
It's just
allowed?
the way that it's being worded in the book is what confuses. Well, that's what confuses me.
I agree. Sometimes they do that. You can always let me know a certain problem. If there's a problem like that, is it like the glacier problem? Is it worded weird? Or are you just talking in general?
Just in general.
Yeah. I understand. It depends on the math person you're working with. Sometimes we don't know how to put words into sentences and stuff. Okay. So let's see. Yeah, and then the other thing I should talk about is the other thing you need to know for that glacier problem in, what is it, section 2.4? So this glacier problem is number 6, I think. Yes. The other thing you need to know for this problem is how does distance, rate, and time, how do they relate to each other? So the funny thing is, this is a formula you guys have used forever. If I'm going 80 mile an hour and I go for 3 hours, how far did I make it? Good Lord. If I travel
240 miles.
Yeah. So distance equals rate of travel times time. So distance equals rate times time. So that would be distance for this problem. It would be 80 miles an hour that I'm going, the rate that I'm going times 3 hours. In fact, let me put the units in there. 80 miles per hour times 3 hours. Now look what happens. What units cancel?
The hours.
That's why it comes out to be just straight distance, because miles are still there. So what if I knew how far I had to go? I got to go 400 miles. And let's say I know that I can go 80 mile an hour. How long is that going to take me to go that far?
Maybe 400 times 80.
No. Distance equals rate times time. Then you divide by 80. Do you really need the formula? You really shouldn't, but it's here for you, right? So if I have to go 400 miles and I go 80 miles every hour, how would I figure out how many hours it takes me to go? Doesn't it, you don't necessarily even need algebra. Of course you're going to divide. Right?
But you just divide 80, 80, how many times 80 goes into 400?
Yeah, exactly. Yeah. So you can see it algebraically here, or you can just reason it out. 1 hour would be 80, 2 hours would be 160. Oh, I've got to divide this to see how many 80s to get to 400, right? But algebraically, you can see it happening here also. So the time would be 5 hours.
5 hours.
Yeah. So that is something you're going to need in one of the parts in that glacier problem. It's this distance, rate, time. It's dirt. Distance equals rate times time. Okay. All right. So let's see what time we got. Okay. We're actually going to do a little bit of new stuff if there's no other questions. We're going to try it. We're going to do it. I want to ask you to get us ready for this next section. No, I don't want to do that. I'm going to ask you some of my own questions. Yeah. All right. I don't know how much anyone's ever explained to you how to estimate things. Because you'll see me up here estimating things and getting pretty close because I know math really well. You know, that's the only reason. But I don't know if anyone's ever actually told you just how to estimate. So if you had to estimate, I don't want you to actually do this. Put your calculators away. I want you to estimate. What is 1092.7 times what, Jeff? 2.018. This is a really unbelievably useful skill that I don't think is taught enough. I'm sorry, go ahead.
2200? Oh, 2200? 2200? 2200?
I'm with you. That's one way to do it. So what Vu did is, what is that close to?
1100.
1100. And what is that close to?
2.
2. I like it. So 2200. I like it. You could also take both of these now. Now watch, if I did it this way instead, so that's not bad. This is an estimate, remember? So hopefully nobody actually put it in the calculator. So what's nice about this is, do you see how that one went a little bit up and that one went a little bit down? So they kind of balance each other out, right? Let me stop for a minute. So some of us have more experience with this. So this kind of just makes intuitive sense. Depending on what job you've ever had, you might have had to do this kind of thing more often or not. Now, what if I did this? Sorry, go ahead. Go ahead.
When you say it went a little bit up and a little bit down, I mean, I'm looking at what you did and I understand that, but what do you mean by that? This one went a little bit up, the first.
Didn't this one go a little bit up when I estimated it? I took 1,000.
Oh, I see what you're saying. You estimated, you rounded it up, yeah.
And rounded that one down. So
yeah,
overall,
rounding.
they would balance each other out roughly.
Okay, rounding. Okay, that's what you meant. Okay, gotcha.
Yeah. Now, just to incorporate some of the symbols they're going to use in this section. So this is the best way to guess this, is to make it balanced out. That goes up a little bit, that goes down a little bit, that balance it out. That should be close. Another way to do it is to just take them both down and make them both totally whole numbers. So make that go to 1,000, make that go to 2. So then it's about, so I should be using, well, anyway, I'll show you in a minute. So that would be 2,000, which is obviously less than this. How does that relate to the real answer? If I make that go down and that go down, is that going to be more or less than the right answer? if I take both numbers down a little bit
Less.
and when I multiply them? Sorry, say it again.
Less.
Less. So that would mean that 2,000 is less than what the actual number would be if I do this, right? 2,000 is less than what this really is. Let me stop for a minute. So there's the less than symbol we should all be familiar with. All right, so that's going to be a little bit less than because I took both of these down a little bit. So that's still a valid estimate, but I know it's a little below what I wanted, what it should really be. This one we did a pretty good job on. I would say that 2,200 is roughly equal to 1,092.7 times 2.018. Is approximately. Have you guys ever seen that symbol? Approximately? Okay. Can somebody go ahead and what is the answer to this? If you put it in your calculator, what do you actually get? Can nobody? Can you guys do that?
2205.
2205, what? 2205.
0.0686.
I like it, blah, blah, blah. So isn't that, didn't we get really, really close using Vu's approach, which is the right approach because you kind of like balance it out? Or you could make them both whole numbers, but that means you have to realize that the answer you got is, in this case, a little less than what it's supposed to be, which again, you can see it is. It depends on how close you want to be. All right, maybe. All right, let's try a different type. I'm going to erase all this. So this is one trick I use when I do stuff in my head. It's just I know a few other tricks that makes me even get a little bit closer, just close enough to make it impressive. So what about this? What do you guys, how would I estimate this? What do you got, Jeff? I don't know. Yeah, let's say 11.86 divided by 2.91. All right, why am I getting a billion emails all of a sudden? Let's see, what do you guys think about this? So here I'm dividing, I'm not multiplying.
Or
I estimate. I
Go ahead, sorry.
estimated 12 and 3.
Yes. But look what symbol I used. I didn't use less than or greater than. I used approximately equal to because, let me see if this makes sense. When I'm multiplying, to keep it about the same, I have to make them balance out. So if I make one go up a little bit, I got to make the other one go down a little bit. When I'm dividing, I want to make them both go the same direction. And we already know both of these things. Watch. So when I'm dividing, can you reduce, what is 14 over 20 equivalent to? Reuse that thing.
7/10.
7/10. So the 14 divided by 20 is the same number as something less divided by something less. So we've known forever that in order to keep the same number, I've got to make the top and the bottom either both go up or both go down. We've actually known that forever. So what do we do here? We made both of them go up a little bit. That's why it stays approximately equal to. All right, let me stop for a minute.
So what if it was like 2.3?
Yeah, then you could, so just like we did a minute ago, I love that question. We could break the rule, but then we have to realize, so if it was 11.86 divided by 2.3. So if I make this go up to 12 and I make this go down to 2, just stay with me, right? That's what you want to do here, isn't it?
Right. I guess you do 2.5, but okay, I see.
Well, 2.5 is not easy to do in the head necessarily. Yeah. But then I've got to realize if I divide, so what I've done is I made this number increase and I divided by less. When I divide by less, does my answer get bigger or smaller?
Bigger.
Yeah, bigger. So this will be bigger than that because I went against the idea. I didn't make both of these go in the same direction, just like we did with the multiplication. Well, what is 11.86 divided by 2.3? Let's do that one first. Let's see what that really is. What really is this?
5.1565.
And it is less than 6, right? I mean, that's an estimation, which could be fine depending on the situation. It depends on how close you need to be. What about this one? This one should be a lot closer. See, this was this was bigger. 6 is bigger than this. Well, somebody do this for me. What does that come out? It should be decently close to 4. Let's find out. So what does that actually equal?
4.075. It's a bunch of other stuff.
4.07, blah, 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 blah. And that's much closer, right? Do you see that? These are much closer to each other because I maintained the ratio. I made them both go up a little bit. If I make one go one direction and the other go the other, it's going to be further off.
Yeah.
The estimation, yeah.
What I'm noticing is those signs in between that approximately and what's that, less than?
Yeah, why did I put this here? Because I knew the changes I made made this bigger than what it used to be.
Right.
Yes, okay, I like it. So then I know if I didn't have a way to do this in my calculator, if I didn't have my calculator with me and I had to do this very quickly, I would know that 6 is bigger than what this actually is. So depending on the situation, I could kind of work with that. So it's sort of like, here, let me give you a different situation. So what if you're at a restaurant and you have a really good waiter? So you have a meal with some friends and it comes out to be $97.82, right? And you want to give them a 20% tip. So how could I round this to make it easier to work with this? So I'm going to estimate.
Move the decimal.
No. First thing I'm going to do is round this to make it a nice round number.
Okay, yeah,
$100.
So I can make it as about $100. And now 20% of 100 is easy. Hopefully. What's 20% of 100?
$20.
20, exactly. So you would be fine with leaving them $20. It's a little, is it more or less than 20% of the meal?
More.
$20. It's more because you rounded that up. But you're fine in that case because they were a good waiter, so what the hell? Give them a little bit extra. What the hell? Yes? So depending on the situation, you sometimes want to overestimate or underestimate just to be safe. So if you're like, how many chairs are we going to need? And they're like, I think it's about 400 people going to show up. Then you get 420 chairs, right? Just to have a few extra in case more people show up. So in some cases, you want to round things up. Sometimes you want to round things down. You want to overestimate, underestimate. Okay, maybe.
There was a little cool trick for tips in the book.
Yeah, exactly. So I'm going to get into that. So I wanted to kind of transition into percentages through this problem here. There's a lot of cool shit what you can do with percentages. All right. So I knew you were headed that way, Vu, and I didn't want to get there yet. I wanted to make the connection. So let me erase this. Let's do a more generic percentage. So if I had to figure out, 15% of 81.05. And and I was going to estimate this. First thing I would do is I would estimate the 81.05. All right, I think I've shown you this before. I can't remember. What's 10% of 80? That should be a quick one.
8.
8. Is everybody cool with that? Because 10% is 10 out of 100 is 1/10. So 10% of something is just 1/10 of that thing. I moved the decimal back once. So if 10% of 80 is 8, what's 5% of 80?
4.
4.
Yes, half, right? So then what's 15% of 80?
12.
Well,
Oh, 12.
yeah. I like it. So very often, if you can relate a percentage to 10, that kicks so much ass. In fact, let's do something else. Let's see. How much time do I got? Okay. Okay, let me see. I'm going to let you finish copying that. Will this be a little more or a little less? I just erased the original problem. But remember, it was like 81 something.
Less.
So it's going to be a little less than it's supposed to be. I like it. So let me give you a different problem. What if I had to do 9% of 400 and let's say 403.97.
$40.
Like 40.
Yeah, tell me how you did that. What'd you do?
10, rounded it to 10, and then 400.
Yeah, you made this one go up a little bit, and you made this one go
Down.
down a little bit, right? You made them nice whole numbers, right? And of course that makes sense because what does of mean? Of means multiply. So if I'm multiplying, if I make one piece go up a little bit, the other piece should go down a little bit to keep it about right. So that's how we get 40. So that should be really close to what the real answer is. Well, close enough. Okay, maybe. So in this section, there's going to be some calculation estimations. What do I mean by that? I mean like what we're doing. These are calculation estimations. There's also going to be some visual estimations. What do I mean by that? Well, let's see. This will be the last thing I show you, and then we'll head out. So the visual estimations are going to look like pie charts possibly and other things. Let me see. Bring the nice problem. Where do you got a nice problem? Well, all right, this will be one place. This is not a pie chart, but this will work. Here we go. Okay. So cost of homeowners insurance. So estimate for California. What would your estimate be for California? So you can estimate a little precisely, a little, well, you know.
82 or so.
Yeah, 82, 81, 83, somewhere in there, right? It's a little bit more than 80. Is that cool? So that's visual estimation. So that shouldn't be crazy. And then you can answer, is it high or low? It depends on how you feel you got it. So if you said 80, it's obviously too low, right? If you said 82, you might be like, I don't think it's too low or high. I think it's exactly right. Why are you up there? I don't know. There also is some talk about these things here. Inequality symbols and the words that go with them. So I think next time we're going to focus more attention on these. There's an earlier chart they have here. Where'd it go? I think it's right here. Here we go. Where they have some specific examples about just greater than and less than. But those are very basic. I mean, that's exactly what 10 is less than 12. So 10 is less than 12. I write exactly what they said. No big deal. But
Right.
the thing that gives people trouble is when I start saying at least and at most, like they talk about down here. So at most means that or less. And that's why that's the symbol I would use. Less than or equal to. Right? If you can have at most 6 people in an elevator, you're going to kick that 7th person out, right? It can be up to 6 in that case, less than or equal to. And at least is the other way around. So people have trouble with those and how they translate into math a lot of times. So that's another part of this section is about those symbols and what they mean. All right. So I think next time what I want to do is I'm going to go step by step. Now this right here, this is interesting. The last thing I think I'll say is this. This is really good for doing true word problems, which we're not doing yet. True word problems are things like a train leaves Wyoming going south at 80 miles an hour, another train going north at whatever, and how long until they crash. And so you have to set up equations. You guys with me? Word problems, real word problems. And those are the things that most students hate. This is a plan to get through word problems, but you can also use it just to get through any problem. And this is why I said, somebody asked, I don't think it was in class, I think it was somewhere else. They said, I have to read through a problem a few times. Can you tell me how to correct that? Right? They felt that was wrong. And I said, no, that's part of the process. You're supposed to read through a problem a few times. You do it quickly at first just to get a general idea so that when you read back through, you know what to focus on. So you're going to have to read a problem a few times before you can start working on it. That is part of the process. So that is definitely not a problem. It doesn't mean you're making a mistake. Nobody, I don't care how good at math you are, can just read a problem once and know exactly what to write. Not even me. I'm not that good. I get a quick idea when I read through it, and then I go slower and get the details. That's how it works for everybody. Okay. So this section is mostly based on estimation, but it also has some ideas about how to read through a problem. Be careful to make sure you're doing it correctly. Okay. So next time we'll focus on some of these group problems. And let me see. I want to show you what I was talking about earlier. I think in the homework they have here. Yes, so there's a beautiful pie chart where you get to estimate what the percentages are here. That's another visual example of estimation. I like it. So for example, that blue is not quite how much?
Half.
It's a big old, it's not quite half. So then you can figure out how to estimate that, right? And then you go to this guy and so forth. I like it. So you can estimate what percentage each of those colors are. All right, I think that's enough for today. So tomorrow we'll get back into this section, 2.5, do some of the group
I have
work.
one question.
Yes.
It's
Sure.
about the prep skills for the section 2.4. I think it's a little bit related to the question to the section 2.5. And is asking, the pie, like how many students get AD or better on the final. Like, do you
Yes.
think like we should like add all the over the D ones, like the percentage?
You can. Well, including D, right? A D or better.
Yeah. So it's like D and C and A and B.
Yes.
Add them all together and then divide them, or I'm not sure.
Well, and then, so what percentage got an F, for example, just to do an example?
An F, it's 19
19% of what?
of 100, I think.
No.
It's
no. How
or
many
no, of
students?
the 31 students.
There we go. 19% of 31. And what does of mean?
Oh, like the sum of the whole. I don't know.
No. Anybody remember? I mean, that's the
Multiply.
big multiply. Yes. Of means multiply.
Oh, okay.
Would do 0.19 times 31 if I needed to know how many students made an F. And then I want you to think about, I just gave you possibly a shortcut on how to do 2C. Because if I know how many made an F, you should be able to figure out how many made not an F, right? Which is what part C is talking about. Or you can do, like you said, add up all the percentages and take that percentage of 31, which means multiply. I like it. Kick ass. Okay, so I'll say it's officially the end of class. If you have any questions, let me know. If you want to hang out and ask some questions. Otherwise, you are free to log out. You guys all right?
Thank you, Professor. Have a good day.
You're welcome. Okay. Well, okay. All right.
Having two
Oh,
at 12:30, right?
yeah, I've got my, yeah,
Okay.
I've got my extra office hours. Yep.
Okay. See you at 12:30.
Okay.